The Cummins N14 didn't arrive with flashy technology. It didn't promise to reinvent the diesel engine. It wasn't the most powerful truck engine ever built. Yet somehow, decades later, mention its name at a truck stop almost anywhere in North America, and you'll still see veterans smile. Some will tell you it was the last truly dependable engine. Others will swear they drove one past 2 million miles. And a few will quietly admit they'd buy another tomorrow if they could. But how did a straight-six diesel from the early 1990s become one of the most respected engines in trucking history? And why do thousands of owner-operators still search for used N14-powered trucks instead of newer machines packed with electronics? The answer isn't just about horsepower. It's about a moment in trucking history when reliability meant survival, when every breakdown could destroy a business, and when one engine quietly earned a reputation that no marketing campaign could ever buy. To understand the N14, you have to go back to a very different America. The late 1980s were a turning point for trucking. Freight volumes were exploding. Highways carried more goods than ever before. Independent owner-operators were growing in number, and competition was becoming fierce. Every mile mattered. Every gallon of diesel mattered. Every unexpected repair could wipe out weeks of profit. The trucking landscape was transforming rapidly. Deregulation had opened the market to new competition. Small carriers and independent operators suddenly found themselves competing against massive fleets with deeper pockets and negotiating power. Profit margins grew thinner. Customers demanded faster delivery times. Fuel prices fluctuated unpredictably. In this environment, equipment reliability wasn't just convenient, it determined whether a trucker stayed in business or lost everything. Drivers worked brutal schedules. 14-hour days were common. Time off meant no income. Breaking down on the side of the highway didn't just mean inconvenience. It meant tow truck bills, hotel expenses, repair costs, missed deliveries, angry customers, and lost contracts. For an owner-operator with a mortgage and a family depending on that next paycheck, a single catastrophic engine failure could trigger financial disaster. This was the world that demanded something better. Engines at the time were expected to do something almost impossible. They had to pull heavier loads, run longer hours, burn less fuel, and survive hundreds of thousands of miles with minimal downtime. Drivers weren't asking for luxury. They wanted an engine that would start every morning, climb every mountain, and bring them home without emptying their bank account. Cummins already had a legendary reputation. For decades, the company had built engines trusted in agriculture, construction, military equipment, and heavy trucking. But regulations were tightening. Customers wanted more power without sacrificing reliability. The famous Big Cam engines had served the industry well, but the next generation needed to do even more. The Big Cam series had earned genuine respect. These mechanical diesel engines powered countless trucks through the 1970s and 1980s. Drivers appreciated their straightforward design and robust construction. Mechanics could rebuild them with basic tools and knowledge. But as highway speeds increased, trailer weights grew, and fuel efficiency became critical, even these proven workhorses faced limitations. Competitors were innovating. Detroit Diesel continued refining their two-stroke designs. Caterpillar was making aggressive moves into the on-highway market. International had their own loyal following. The diesel engine market was intensely competitive, and manufacturers that failed to evolve risked losing market share permanently. Cummins needed something special. That's when engineers introduced something that looked familiar on the outside but was dramatically different underneath. The Cummins N14. At first glance, it seemed almost ordinary. An inline-six diesel with a displacement of 14 liters. Massive cast-iron construction. Gear-driven accessories. A design philosophy centered on strength instead of complexity. But hidden inside was one of the biggest engineering improvements Cummins had ever made. The N14 introduced the CELECT electronic fuel management system on many versions, replacing purely mechanical control with electronic precision. That might sound normal today, but back then it was revolutionary. Electronics could control injection timing with incredible accuracy. Fuel delivery became smoother. Efficiency improved. Emissions dropped. Cold starts became easier. Drivers noticed better throttle response without giving up the rugged reliability they expected. The CELECT system represented a fundamental shift in diesel engine philosophy. Before electronics, fuel delivery depended entirely on mechanical pumps, springs, and governors. These systems worked, but they lacked precision. Injection timing remained relatively fixed regardless of operating conditions. Electronics changed everything. Sensors monitored engine speed, throttle position, coolant temperature, intake manifold pressure, and dozens of other parameters. The electronic control module processed this information thousands of times per second, adjusting fuel delivery with precision impossible in purely mechanical systems. This technology delivered tangible benefits. Fuel atomization improved, creating more complete combustion. Power delivery became smoother across the RPM range. Cold weather starting reliability increased dramatically. Altitude compensation happened automatically. Drivers experienced better drivability without understanding the complex engineering making it possible. Some truckers were skeptical. Electronics in heavy-duty trucks? Many believed computers would never survive years of vibration, dust, freezing winters, and desert heat. The skepticism was understandable. These trucks operated in environments that destroyed consumer electronics routinely. Temperatures under the hood could exceed 200 degrees. Vibration was constant and severe. Moisture, road salt, and diesel fuel created hostile conditions. Computer chips seemed fragile compared to cast iron and forged steel. Ironically, the N14 proved that modern electronics and old-school durability could actually work together. Cummins engineered the CELECT system specifically for harsh commercial vehicle environments. Sealed connectors resisted moisture and contamination. Robust sensors withstood vibration and temperature extremes. The electronic control module featured protective housings and redundant circuits. Quality control during manufacturing ensured reliability that gradually won over even the most skeptical operators. Under the hood, the specifications were impressive for the era. Horsepower ranged from roughly 310 to over 500 depending on configuration. Torque reached well above 1,850 pound-feet in high-output versions. That massive twisting force allowed heavy loads to move without constantly downshifting. The variety of available configurations meant the N14 could serve multiple applications. Lower horsepower versions worked well in regional delivery trucks that prioritized fuel economy over maximum performance. Mid-range options suited general freight haulers balancing power and efficiency. High-output variants served heavy-haul operators moving oversized loads, specialized equipment haulers, and operations where maximum pulling power justified slightly higher fuel consumption. And that's where drivers truly fell in love. Anyone can build horsepower. Torque is what pays the bills. Imagine pulling 80,000 pounds up a long grade in the Rocky Mountains. A weaker engine forces constant gear changes. Every shift costs momentum. Every lost mile per hour costs time. But the N14 produced its torque low in the RPM range, allowing drivers to stay in gear longer while the engine simply kept pulling. Experienced drivers understood this intimately. Horsepower numbers looked impressive in sales brochures, but torque determined real-world performance. High torque at low RPM meant the engine didn't need to scream at maximum revolutions to move heavy loads. Drivers could operate in the engine's sweet spot, typically between 1,200 and 1,600 revolutions per minute, where fuel efficiency, reliability, and performance balanced perfectly. It wasn't dramatic. It was dependable. And dependable is exactly what trucking companies needed. One of the secrets behind that dependability was Cummins' continued use of a robust wet liner cylinder design. Instead of boring cylinders directly into the engine block, replaceable liners surrounded by coolant made overhauls far easier. When the engine eventually wore out after hundreds of thousands, or sometimes well over 1 million, miles, mechanics could rebuild it without replacing the entire block. The wet liner design represented old-school engineering wisdom. These removable steel liners fit into the engine block with precisely machined tolerances. O-rings and seals prevented coolant from entering the combustion chamber while allowing heat transfer to the cooling system. When cylinder wear eventually occurred, mechanics could remove the old liners, inspect the block, and install fresh liners along with new pistons and rings. This approach offered enormous economic advantages. A complete in-frame overhaul could restore an N14 to nearly new condition for a fraction of the cost of engine replacement. The process didn't even require removing the engine from the truck. Skilled mechanics could complete the work in a well-equipped shop over several days. That changed the economics of trucking. An overhaul cost money. Buying a brand new engine cost far more. For owner-operators living load to load, rebuildability wasn't just convenient. It could save their business. The difference was staggering. A new engine might cost $30,000 or $40,000. A quality in-frame overhaul might run $8,000 to $12,000, depending on parts quality and labor rates. For a small trucking operation with tight cash flow, that difference determined whether they survived a major maintenance event or went bankrupt trying. Then there was maintenance. Experienced mechanics often described the N14 as one of the most approachable heavy-duty diesel engines ever built. Components were accessible. Parts were widely available. Problems were usually straightforward to diagnose. Unlike later engines buried beneath emissions hardware, the N14 rewarded technicians who understood diesel fundamentals. Accessibility mattered enormously during repairs. Fuel injectors could be removed without major disassembly. The water pump sat in an easily reached location. Oil and fuel filters mounted where mechanics could service them quickly. Valve adjustments required patience and proper procedure, but the process was logical and well documented. Parts availability reinforced this advantage. Cummins maintained an extensive dealer and distributor network across North America. Major components were usually available within hours, even in remote locations. Common maintenance items like filters, belts, and hoses could be found at truck stops and parts stores everywhere. Of course, no engine is perfect. The N14 developed its own list of common issues over the years. Injectors occasionally failed. Camshaft wear could appear in high-mileage engines. Electronic sensors sometimes caused frustrating diagnostic problems. Cooling systems demanded proper maintenance. Ignoring valve adjustments could eventually reduce performance. Injector problems typically announced themselves clearly. Rough idle, excessive smoke, poor fuel economy, or loss of power pointed toward injection issues. Camshaft wear often resulted from inadequate lubrication or extended oil change intervals. Electronic sensor failures occasionally created diagnostic challenges that required systematic troubleshooting. But here's the important difference. Most failures were predictable. Preventive maintenance usually prevented catastrophic damage. That predictability created trust. Drivers knew what to expect. Fleet managers could schedule repairs instead of reacting to disasters. Mechanics carried the necessary parts. The entire industry gradually learned the engine's personality. This predictability represented perhaps the N14's greatest achievement. Catastrophic failures were relatively rare and properly maintained examples. Most problems developed gradually, providing warning signs that attentive operators could recognize. Oil pressure dropping slightly. Coolant consumption increasing. Subtle changes in exhaust smoke color. And that's something newer platforms often struggled to achieve. Fuel economy also became a major selling point. Although actual mileage depended on gearing, driving style, terrain, and load weight, many operators reported significant improvements compared to older engines they had replaced. Saving even half a mile per gallon might not sound impressive to someone driving a passenger car. For a truck covering 120,000 miles every year, those savings became enormous. The mathematics were compelling. A truck averaging 120,000 miles annually at 6 miles per gallon consumed 20,000 gallons of fuel. Improving to 6.5 miles per gallon reduced consumption to roughly 18,461 gallons, a savings of over 1,500 gallons yearly. At diesel prices ranging from $2 to $4 per gallon, that represented $3,000 to $6,000 in annual savings. Over several years, improved fuel economy could offset much of the engine's purchase price. That's why fleet executives paid attention. Every fraction of efficiency mattered. Meanwhile, drivers appreciated something less measurable: the sound. The N14 developed one of the most recognizable exhaust notes in North American trucking. Deep, confident, smooth under load. Not excessively loud. Just enough mechanical character to remind everyone that 14 liters of diesel power were working beneath the hood. For many truckers, that sound became the soundtrack of an entire career. Thousands of miles through Wyoming. Snowstorms in Montana. Desert crossings in Arizona. Rush hour traffic outside Chicago. The engine became part of their memories. Sound might seem like a trivial consideration, but it profoundly affected driver experience. Truckers spent 10, 12, sometimes 14 hours daily in their cabs. The engine's voice became constant background to their working lives. The N14's characteristic tone, authoritative without being abrasive, made long days more tolerable. Then came an even bigger challenge. Government emissions regulations grew stricter throughout the late 1990s and early 2000s. Manufacturers faced enormous pressure to reduce nitrogen oxide emissions and particulate pollution. Every major engine company scrambled for solutions. Some relied heavily on exhaust gas recirculation. Others experimented with increasingly sophisticated electronic controls. Environmental concerns had gained political momentum. Studies linked diesel emissions to respiratory problems and urban air quality issues. The Environmental Protection Agency established progressively stricter emissions limits that required fundamental changes in diesel engine design. Cummins continued evolving the N14, improving calibration and emissions performance while attempting to preserve the characteristics customers loved. But physics and regulations eventually collided. Cleaner emissions required more complexity. More complexity meant additional components. Additional components introduced new failure points. The industry was changing, whether drivers liked it or not. Eventually, the N14 reached the end of its production life, replaced by newer engine families designed around modern emissions requirements and evolving electronic systems. On paper, the replacements often looked superior. Higher power, advanced diagnostics, better emissions compliance. More computing power than anyone imagined possible during the early 1990s. Yet something unexpected happened. The legend of the N14 only grew stronger. Why? Because nostalgia alone doesn't keep equipment alive. Performance does. Across North America, rebuilt N14 engines continued powering logging trucks, dump trucks, heavy-haul rigs, oilfield equipment, and owner-operated highway tractors. Independent rebuild shops specialized in keeping them alive. Salvage yards discovered growing demand for usable engine cores. Aftermarket manufacturers continued producing replacement parts. An engine only earns that kind of support when people believe it's worth saving. Some operators even search specifically for pre-emissions trucks with N14 power plants, accepting older cabs and outdated interiors simply to avoid the complexity of newer emissions systems. That decision wasn't always about technology. It was about trust. Trust built over millions of miles. Trust earned during freezing nights when the engine started anyway. Trust proven after crossing mountain passes year after year without complaint. Of course, no honest discussion can pretend the N14 was invincible. Poor maintenance shortened its life dramatically. Overheating could damage expensive internal components. Neglected cooling systems caused problems. Improper rebuilds ruined otherwise excellent engines. Cheap replacement parts sometimes created headaches that original Cummins components never did. Like every diesel engine, longevity depended on discipline. Regular oil changes. Quality filtration. Correct valve adjustments. Cooling system maintenance. Proper driving habits. Owners who respected those fundamentals often received extraordinary service life in return. Stories of N14s exceeding 1 million miles weren't rare myths. They were documented reality. Some engines reached 1.5 million miles. A few exceptional examples reportedly exceeded 2 million miles with proper maintenance and timely overhauls. Perhaps the most remarkable achievement of the N14 wasn't any individual specification. Not horsepower. Not torque. Not fuel economy. It was consistency. Thousands of engines performed nearly the same job every single day for decades. No headlines. No viral marketing. Just dependable work. That consistency built reputations far more powerful than advertisements ever could. Today, younger drivers entering the industry may never experience an N14 during everyday freight hauling. Many have grown up with engines filled with sensors, variable geometry turbochargers, aftertreatment systems, diesel particulate filters, selective catalytic reduction, and software updates. Those technologies undeniably reduced emissions and improved many aspects of diesel performance. But ask experienced truckers what they miss, and the conversation often returns to engines like the N14. Simple enough to understand. Strong enough to trust. Efficient enough to make money. Durable enough to become part of the family. Even mechanics who spent decades repairing heavy equipment often speak about the N14 with unusual respect. That's rare. Mechanics usually remember engines for the problems they caused. The N14 earned respect because it rewarded careful maintenance instead of punishing it. Maybe that's the real reason drivers never forgot it. Not because it was perfect. Because it was honest. It delivered exactly what it promised. In an industry where schedules slip, weather changes without warning, freight rates fluctuate, and every breakdown carries a financial cost, honesty matters. The Cummins N14 represented an era when engineering focused relentlessly on durability, serviceability, and practical performance. It became more than a diesel engine. It became a business partner. A livelihood. A companion through countless lonely highways stretching across an entire continent. Long after production ended, the stories continued. Stories of engines passing 1 million miles. Stories of rebuilds that brought them back for another decade. Stories of fathers teaching sons how to adjust valves on the very same engine they trusted throughout their own careers. Machines rarely become legends. People make them legends. But every once in a while, a machine earns that status through decades of faithful service. The Cummins N14 did exactly that. It didn't change trucking with flashy innovation or revolutionary styling. It changed trucking by proving that reliability could become a competitive advantage, that intelligent engineering could simplify ownership instead of complicating it, and that an engine built to last would always have a place in the hearts of the people who depended on it. And perhaps that's why, even today, when the conversation turns to the greatest diesel engines ever built, the Cummins N14 is never far from the top of the list. If you enjoyed this journey into one of trucking's greatest legends, make sure to subscribe for more stories about the engines, trucks, and innovations that shaped America's highways. And tell us in the comments, if you ever drove an N14, what memory still stays with you after all these years.